Hello everyone, welcome back. In today's video, I'm going to explain how the JavaScript engine executes our code, how it runs our program, the order in which our JavaScript code gets executed. And this should be fun. So I'm going to use this code snippet here to explain what happens or how the JavaScript engine executes our code under the hood. So the first thing that happens when this program runs is an execution context gets created called the global execution context, right? An execution context is just an environment in which JavaScript code runs. And for each program, we have one global execution context. We can have as many function level execution contexts, and we're going to see one function level execution context, but the main execution context is the global execution context. Now, another thing the JavaScript engine has is what we call the call stack, right? The call stack is a data structure, sort of a data structure that helps JavaScript keep track of functions that have been invoked. It helps JavaScript keep track of where the thread of execution is currently, what the thread of execution is currently executing. And we're going to see more about the thread of execution and the call stack, but I'm mentioning it now because immediately our program runs, the global execution gets created. A new execution context gets created. That's the global execution context, and it gets added to the call stack. So the global execution context is always at the bottom of the call stack. This is the first thing on the call stack. So whatever is at the top of the call stack is what the thread of execution is currently executing at the moment. And now we have the global execution context. That's why I'm mentioning it now, but we'll see more about the call stack later. Now, the global execution context has two phases, right? The memory creation phase and the code execution phase. So the first one is the memory creation phase. During the memory creation phase, it extracts out the declarations that are in the global space or global environment of our program. It extracts out the variable declarations, the function declarations, and assigns a memory, allocates a space in memory for them. And another name for this memory is the variable environment. So during the memory creation phase, the variable declarations, the function declarations gets allocated a space in memory or a space in the variable environment. And then when it's done with the memory allocation phase, it then goes ahead to start the code execution phase. So let's go through the memory creation phase for this our program, just the way JavaScript would. Let's go through the memory creation. So on the first line, we have a variable declaration that says var a is equal to 10. Now, in the memory creation phase, the value 10 is not important here. It just assigns or allocates a space in memory for the variable a. The value 10 is not important. In the memory creation phase, it doesn't assign values. It just goes through the code and creates a space in memory or in the variable environment for the variables. It doesn't assign their values yet, but A will get assigned during the memory creation phase. A will get assigned the value undefined. The value 10 will not be assigned to A until the code execution phase, until it starts executing the code. So that's the first one. On the second line here, we have a function definition. And when memory is allocated for functions, it copies the entire function body. It copies the entire code, everything in that function, and allocates it a space in memory, and then assigns it the label. The name of the function is used as a reference or a label to that function, right? So our entire code inside the say hello function here is going to be copied and then assigned to say hello and say hello will be assigned to it as a reference, sorry. And then it moves to the next line. On the third line, we have another variable declaration. Look at that. Do you see what happened? It did not enter the function body. It skipped the function body. So the thing is, it doesn't access the content of our function, of our say hello function here. It doesn't access the content because the say hello function has not been called. It has not been invoked. right? So it just assigns the variable b a space in memory. It doesn't assign it the value 20 because we're still in the memory creation phase. It just assigns it undefined and moves to the next line. The next line, we have another variable, right? Greet adder, and it's assigned the value of calling our say hello function. It's assigned the value of invoking the say hello function. So at this point, the memory creation phase, it just gets assigned a space in memory, and temporarily its value is just set to undefined. So that's it for our memory execution phase, right? JavaScript is done with our memory execution phase because we've gotten to the end of our program. There's nothing else to assign or allocate a space for in memory. Now let's see how it's going to execute our code in the code execution phase. But before that, I want to talk about something. There's something JavaScript has called the thread of execution. JavaScript has something called the thread of execution, right? It goes through our code line by line. It's single threaded. It goes through our code line by line and processes it or executes our code line by line from top to bottom in that fashion. That's why we see JavaScript is synchronous or single threaded, right? This thread of execution can only do one thing at a time. At any point, it can only execute one task at a time from top to bottom. So let's see how the thread of execution would execute this our code snippet here, this code block, our program, right? So the thread of execution starts on the first line, and the first thing we have is a variable declaration that says var a is equal to 10, right? So it looks for the variable a in memory and assigns it the value. We had undefined there before, but now it replaces it with the value 10 and moves to the next line. On the next line, the thread of execution is on the next line. Now we have a function definition, right? Remember, in the memory creation phase, the entire code, the entire text in this function was copied and stored in memory against the label or the reference say hello. So it still doesn't access the content of this say hello function because the function has not been called. It still doesn't, JavaScript would not try to execute code in a function except unless that function is called. So then it moves to the next line, right? Thread of execution is on the next line. And we have another variable declaration, b is equal to 20. So then it looks for b in the memory and replaces undefined with the value 20. So replaces undefined with the value 20 and moves on to the next line. And this line is interesting because we have a variable declaration, right? Greet adder, whose value is currently set to undefined in memory, but here we have a function invocation. We're calling the say hello function and passing in the string adder as its argument, right? So the value returned from calling this function is what is supposed to be assigned to the greet adder variable or the variable greet adder. JavaScript doesn't know what that value is, right? It hasn't invoked the function, so it's going to leave the greet adder variable with the value undefined for the moment and go and run the say hello function. So let's do that. Let's go and run the say hello function. Let's see how it will do that. Let's run the say hello function JavaScript style, if I'm gonna be serious. Okay, so thread of execution has to go and grab the say hello function from memory, pass in the string adder and start executing the code inside it. So let's see how it does that. Oh, this is interesting. So in JavaScript, when a function is invoked, when a function is called, a brand new execution context is created, right, for that function and pushed to the top of the call stack. Do you see the call stack here? I forgot to put the string adder inside, but you get it. So this brand new execution context is created and added to the call stack. So it keeps track, just so that you keep track of what function the thread of execution is currently executing at the moment. Right? So this execution context is just like the global execution context, but this is a function level execution context or a local execution context because it's just for this function. So our local execution context here also has a memory, right? Also known as its variable environment, where its declarations will get stored. If it has any function declarations, variable declarations, they'll get stored in its memory here. And that's what this section on the right is for. And then on the left here is where the thread of execution will execute the code in this function. Thread of execution pauses everything happening in the global execution context, enters this execution context, and starts its memory allocation phase, its memory creation phase, right? So it starts allocating memory to all the variables. We don't have any function here, but it starts allocating memory to the variables declared in this function, right? So the first variable we have in this function is the parameter name, or the name parameter, I don't know. So when a function accepts a parameter, that parameter is also a local variable in that function. The parameter is also a local variable to the function. So we can see that the say hello function here was called with this arguments, this string adder. So this string is what is supposed to get assigned as the value of this name, of the name reference or the name variable here. But we're still in the memory creation phase, so it will temporarily assign undefined as the value and move on to the next line. Right, on the next line we have a variable called greeting, right? And greeting is assigned the evaluated result of concatenating the string hello and the string name, right? But since we're still in the memory creation phase, it just temporarily assigns undefined as the value, as a value to greeting, and moves on to the next line. On the next line, on the next line we have return greeting, right? The greeting variable. So that's the end of the memory allocation or the memory creation phase, because there's nothing else to be added to memory here, or nothing else to be allocated to memory. So then it starts the code execution phase. Let's see how, or let's go through the code execution phase as well. On the first line we have the name parameter, right? So it assigns the string adder to the name variable now in memory and moves on to the next line. On the next line we have the variable greeting, and greeting is supposed to be assigned the result of concatenating these two strings, right? So JavaScript just looks for what name holds in memory. What's the value of name in memory? The value of name is adder, so it does the maths, and the return value is then assigned to greeting. That's the hello adder. And then we move to the next line. On the next line, so on the next line we have return greeting, right? The value that the greeting variable holds, or the variable greeting holds, I don't know why I do this, the value that the variable greeting holds is then returned out of the function, and that's just the string hello adder. So the string is returned out of the function, meaning that that is the end of that function. That function is done. So the thread of execution leaves that function. It goes back to the global execution context and assigns that value to the variable greet adder, right? So greet adder is no longer undefined. The value returned from this function replaces the undefined value. So greet adder now holds the value returned from invoking the say hello function. And then say hello execution context gets removed, right? Because its value has been returned, it's done, so it gets popped off the call stack. And as we can see from here, we're now back to the global execution context, because that's what's at the top of the call stack. JavaScript, at any point in time, if JavaScript wants to know what execution context is in, what function it's executing at the current time, it just looks at what's at the top of the call stack. So we're done with say hello. Control gets handed back to the global execution context, and now our program is done. So the global execution context also gets removed from the call stack, and that's the end. So that's sort of like a hypothetical runtime of how our code gets executed by the JavaScript engine. And we've come to the end of this video. So I hope it was helpful. If there's anything I did not explain well, I don't know if I really explained the call stack well. If there's anything you don't understand, please let me know. I hope the video was helpful, and please subscribe if you haven't already. Thank you so much for watching, and I'll see you in the next one. Bye.